Alright folks, I'm going to try and keep this one short. This is video number 13. It's Thursday the 3rd or 4th of April. I posted a couple of videos there over the weekend, but they were actually recorded a couple of weeks back. And this video is just going to be to update you on what I've done and some of the issues I've encountered along the way. So one of the first things I realised I hadn't updated you on when I reviewed my most recent uploads is the fact that I've now got the table mounted back onto the table bracket. I was missing one of these bolts. They're 5/16 BSF by 1 inch long, so I ordered up a few online and I was waiting for them, so that took a little bit of time to come. It wasn't too long. I've got them mounted now. That's brand new bolts, so they threaded in lovely, and yeah, it looks just a job now, eh? So I've got everything oiled up as well, as you can see, so that should keep for quite some time now before it needs refurbishing again. Right, one of the big changes since my last videos is the fact that I've pretty much got the head completely stripped. As you can see from on the side here, the spring mechanism has been removed. Okay, now I was really concerned about that. I thought that would be quite difficult and possibly a painful experience, but it was actually a lot easier than I anticipated. I spoke to Meddings just to get a little bit of advice regarding the matter, because they're the manufacturers. The lads down in the factory in Devon there, they do this all day every day. They know their stuff. Okay, it's not that complicated item, but there's always tips and tricks to any apparatus when you're dismantling it. Now, this is the spring here. As you can see, it's still retained within the casting or the housing, and obviously the tension's been completely released off it now. Basically, the spring housing is retained in the hole by a grub screw in here. So when you slacken the tension on that grub screw, the whole housing can rotate, right? And that actually in turn can drive the handle, yeah? And the handle is also retained by a grub screw on this side. So by slackening both of these grub screws, both the driving mechanism and the spring can be extracted. You'll find that the tension releases on the spring before you actually disengage the shaft from the catch part of the spring there, which means that it just simply the tension releases. It doesn't spring off out of the housing. It's really quite safe to remove it. Putting it back on and re-engaging the mechanism won't be a problem. Getting the spring tension back, I've been told, doesn't require any specialised tooling, and it's just a case of a little bit of trial and error until you get the correct point to nip the grub screws up and have the machine or the quill operate as it should. So I'm no longer worried about reassembling this part of the machine. The next thing that's kind of stopping me is the fact that, if you can hear that there, it's obviously got some form of stop preventing it from being completely extracted. I haven't determined why that can't be removed yet. You know, I haven't stripped the bearings yet. The circlip is still retaining the bearing on this end, and it's proven to be quite a strong circlip. So my circlip pliers weren't sufficient for the job. But I think I do have a pair of long-nosed pliers that will suffice. What else was there? Oh yeah, the handle now, or the drive shaft, whatever you want to call it, has been removed. You can see it's suffering from quite a lot of dirt and rust being in about the mechanism. It's obviously been apart before, because there's various marks where they've, if you look here, they haven't actually released the grub screws which hold this in place, and I think they've possibly drifted it out, causing, you know, some damage to that diameter there. There's a few instances of that there also. And then there's also marks where the grub screw's taken a bite into the shaft. Yeah, you know, in the day they would have probably had a brass plug to prevent that from happening, but, you know, cost cutting, what can I say about that? The actual gear itself, which drives the outer sleeve of the spindle, I noticed that the teeth were just choked with dirt and grime and crap, and I've given them a quick clean, but it's going to require some further cleaning yet, and I'd really like to strip the whole thing out and clean everything. These teeth are also similarly blocked with crud, and I've scraped some of it away, but there is quite significant wear on the profile of the gear teeth. You know, here in the middle, the gear teeth are rounding quite significantly, so that may be a part I will look at replacing, yeah, because the more the gear teeth wear, the more that's going to affect the well, damn, it's not a ratchet, it's not splines, it's the pinion. I can't remember the correct term right now for this form of a tooth, but it's basically the same as what you'll find on the underside of lathes here. You know, I can't remember the name of it right now, but the longer I leave this gear in this condition, the more likely it's going to affect that it affects the, if it hasn't already, affects the teeth on this shaft here, or this sleeve. So I don't want to let any further damage occur, so I'll either replace it or possibly in due course manufacture a new one myself. But that will be a certain profile of tooth, and once the gear was manufactured and to a specific dimension, it would have then have been heat treated and hardened, and then finally gotten a grind to take it down to its final size. So that would be even a small gear like this would be a significant undertaking for a home workshop. Okay, so it might be something that I'll just have to bite the bullet and replace and buy a part from Meddings. I got the pin out. I've actually left the pin at the house. I was going to show you the pin. It wasn't a tapered pin, it was just a solid pin which had been drifted in to place. There were 3 scores on the pin to help it its retention within the body of the shaft. On punching it out, I initially attempted to punch it out with just a little rod which I had lying around. It was just I'd cut it out of a cage, okay, and the cage was like a sort of basket, yeah, type affair, and the metal proved to be too soft for the job in hand. So I scratched my head for a little bit because I don't have a decent set of punches, okay, and screws are pretty tough, eh? So that was the remedy. The end of a, what was that, 4 or 5 inch screw there, and yeah, the head bent slightly while I hammered it, but that proved to be it's obviously high tensile, so it was significantly stronger than the bit of wire that I was using, and that did the job nicely. So got the pin out. The pin came out, and it was actually in 2 halves. You know, they had the top part and then the bottom part at the rear, and it had sheared. Okay, it had been sheared for a significant period of time because the metal across the plane where it had sheared was very dark in colour, suffering from some corrosion and staining. So it wasn't the action of driving the pin out that caused the shear. It had been sheared, and well, it would have needed replacing. Otherwise, it could have possibly caused damage to the inside of this union of these parts. Yeah, and you know, it's not a big deal, like, you know, but it's just one little thing that I've identified. So I haven't looked at the motor recently. I'm going to clean this part of the mechanism up. I'm going to clean up the spring. I was thinking about making a little hardwood cover for the spring, you know, and then getting it polished up and maybe waxed or oiled, just to, you know, make it look presentable. I don't know what wood I'd use. It'd need to be a nice hardwood would be good, but I don't have anything like that lying around. I need to source a bit of wood for that. I'd rather have wood than a bit of plastic, okay? Also, these shafts, which are part of the handle assembly, I think I'd like to replace them. They've suffered quite a lot of corrosion, in so much that the chrome finish has come away, and I only have one of the actual handles which simply push onto the shaft and are held in place by this internal sort of spring clip type affair. What I'd quite like to do is to machine 3 new handles, ball handles out of brass, and 3 new handle shafts out of stainless. I'd have to ensure that this thread was the same as the thread in here, but I could use any thread I wished to actually screw the handle onto the shaft, and that would, you know, it's just tighten it up a little bit, but you know, that's a project for another time. One of the other points I was going to bring to your attention was I have actually sourced a new chuck, which I have. Oh, there we go. which I have got here. Now, it's like brand new, eh? There's no discernible corrosion on it. The teeth are in perfect condition. Well, you know, there's the odd spot or corrosion, but I'm seriously not bothered by that at all. The Morse tape is in perfect condition. There's no dents. There's no bashes. The tang on the end of the Morse taper is likewise in perfect condition. I've got the correct key. The key, there's minor issues with the teeth on the key itself. It's not just perfect, the key, but it's certainly more than adequate to tighten and loosen the jaws of the chuck. And the jaws on the chuck are pretty much perfect, you know. There's a little bit of rounding on the odd tooth, but I mean, when I say little, it's negligible. So I'm really happy with that purchase. Another eBay item. I'll take that over here now before it falls. This chuck, I spent a bit of time cleaning it up and filing off some of the worst of the damage to the body of the chuck, and it rotates freely to a degree. You know, I can rotate the chuck freely there, but as the jaws extend, they start to encounter resistance there, so it can't close any further than that without putting significant force on the chuck key, and I think that's possibly one of the reasons that the teeth have sustained so much damage. And if I wind it all the way back till take a bigger drill, again it gets so far and then it starts to tighten up and they can't really go in any further than that. So I think there is some form of damage inside the chuck. The chuck body, it's been smacked at various places because the chamfer here has sustained damage in a number of places. So instead of using a Morse taper to release it from the, not a Morse taper, but where are they? You know, the Morse taper drift. When you extend the quill here, you've got a slot which, when you turn the spindle, lines up with a hole in the spindle. Yeah, you know, most of you will know this, I'd imagine. And then when the drill is placed in here, that lines up with that hole there. Yeah. So when it's like that, you then take what they call a Morse taper drift, and I seen one there just a bloody minute ago. Now, anyone that works has worked in a workshop knows this happens a lot. Eh? You set something down, and 2 seconds later you can't find it. Well, okay, I'll leave it there now. But basically, all that happens is it's a tapered bit of steel that's hardened, and it just, the nose of it goes in there and pushes up against the side of your spindle, and the other side of it, the taper side, goes tight up against the end of the Morse taper of your drill chuck. Then you give it a tap with a hammer and it wedges in there and pops the chuck off. Right? So it's a simple tool, and So it's a simple tool and easy to use, and you know the drill just pops off and it doesn't do any damage to the drill. And obviously what's happened to you is they haven't had a Morse taper, or they like me have lost it, and they've just come in about it with a mallet or a hammer and possibly bent it or damaged the mechanism, and certainly damaged the chuck body. So that's not the way to do it, folks. Right, so all that's left now to say is that you can see now the head has been, I got the panel for here as well, and this has all been sort of cleaned up somewhat. I'd like to clean it up some more than what I've done there at the moment, but I'm still busy with dismantling it. There's not much left on the head now. All that remains is to take out the spindle, and I've still got to determine how to do that. I'm hoping I can do it without removing the bearings, but that remains to be seen, because I think the bearings are in quite good order, and I don't want to risk damaging them by removing them from the body, because you know that can easily occur when you're removing bearings. What I've got to do is determine why that doesn't come out. There's something retaining that at the moment. It might be, I don't know, it could be a screw somewhere, or I don't know what it is or how it. I think this is all part of this here is all one part, yeah. So this doesn't actually come off of this. So obviously it can't be taken out that way. You know, I can't pull the whole item through the body. You know, common sense, folks. But the spindle here is retained by a circlip there. So whether or not, you know, I think the spindle may need to be extracted, and when the spindle's been removed, you know, there's maybe a part of the spindle in here that's wider, and the spindle's been held tight in here, I'm thinking. So when you pull this out, the wider part of the spindle is interfering, and that's retaining the whole mechanism. So if I release this, say, spring clip here, or circlip here, hopefully I can extract the spindle in this direction, and then this should hopefully come out that way. That's my thought on it at the moment. Time will tell. So that must be about 20 minutes now, folks. So I'll let it go at that. I'm going to try and get this done today, because I'm really quite keen to start painting this, get it all cleaned up, undercoated, enamelled, and then start putting the parts back together, because you know this has been dragging on long enough now. Like I say, I don't get a lot of time up here. You know, I've got other commitments, and yeah, enough said. Hope you're all well, and hope you found this interesting. And until next time, bye for now. Right, folks, I must be running out of memory, so I'll keep this as short as I can. The timer here shows me that I've got 8 minutes and 3 seconds of storage capacity. So yeah, I've had a attempt at getting the spindle and the sleeve out, and as you can see I've been successful, and I'm glad I've done it, because not only is it going to make the painting of the head a lot easier, but I've also determined that there is actually significant damage to the bearing. Right, look at that. You know, I've never seen a bearing as bad as that before, Now, just before you start thinking that, oh yeah, he smacked it too hard with a hammer, I didn't use a hammer, I just used a mallet here, yeah, plastic mallet, and all I was doing was just gentle taps like that, you know, I wasn't putting any force behind it, I wasn't fucking lashing at it from, you know, holding the handle back here. I was just holding it up there and just gentle taps. So I've got it all dismantled now. I'm going to give everything a good clean and grease. I don't know what the purpose of that hole is. There's no threads in it. So maybe an oil hole or something, I don't know. But I've got it apart now, so there's a bearing on this end of the spindle, and there's a bearing in the top end of the sleeve here, and I don't know if you'll see up there, there's a sort of splined shaft up there which locates on those splines, and there's a bearing in there, so that'll be 3 bearings. Now it feels okay, but so did that one, and look at the state of it. I wouldn't have expected that to have been, I don't know what kind of bearing it is. Is it just a normal ball bearing? I can't see with all the dirt on it, So okay, I'm going to pause it there and I'm going to clean everything up and have a more thorough inspection of it. I would have said that's wrong, yeah. You know, bearings are normally meant to be pretty tight. There doesn't seem to be any play this way, you know, back and forth that way with it. But I can't really hold it very. It's all like this. And you know, some bearings possibly no, that can't be right. I'm talking myself in la. But then I know that some bearings you can. They do have a certain amount of adjustment in that sort of manner. So I'll need to investigate this a little bit, but I think at the moment what I'm thinking about doing is replacing just all 3 bearings, just for the hell of it. I've got a dundless sort of point, I may as well get it done, and then the machine will be good for the rest of my days anyway, put it that way. Because I'll not be, you know, using it on a daily basis, I'll just be using it as and when I need to. And you know, three new bearings, maybe 15 quid, 20 quid with postage. I can stretch to that. You know, I got the drill relatively. It was a bargain in a sense, but it was you know, obviously needing a bit of work. So I can afford to put maybe 20 quid out on it, you know, and you know, £10 on paint. So that a total cost of about 30 quid. Well, I spent another £5 on pins. The pin for in here, I could only order the correct size of pins at in 25 for a pack, so that was a £5 for it with postage and packing. So you know, if I spend 40 or 50 quid on the lathe, well, not the lathe, sorry, on the drill, that's not too much, yeah. So yeah, I'm going to save the next 4 minutes just in case I want to record something else. See you in a bit. Bye for now. Okay, so I've removed the circlip of this recess here, yeah, which then allowed me to invert the shaft and the bearing, and having supported the bearing here and here, I then lightly tapped the shaft. Sorry, I'm not looking at where I'm filming. I lightly tapped the shaft out from the bearing, having the bearing supported. Now, I thought it might have been a special bearing, but it's not. It's just a fairly standard ball race bearing, yeah. And there is a lot of play there, eh? Now, what I'm thinking is how it occurred is whoever's fitted it hasn't fitted it correctly. I've had a little bit of think about this. Their erase will be reasonably tight inside, sorry, not inside there, inside here, okay? I would say it's probably pressed in the factory, but if you were to press it in the home workshop, you know, that's obviously a possibility for some people. Alternatively, you could have a drift of the correct diameter bearing on the outer race only, okay, to push that in. Now I'm thinking that they've possibly done that, right, but then realised that it's also got to be pressed onto this. So I think the right order of things would be to press the bearing onto the shaft first using the inner race, and then with the shaft attached to the bearing, have the bearing pressed into the housing using the outer race. And I don't think that's been done because I've only got seconds left, but the shielding for the bearings is warped in places, so I think that's suffered some damage. That's all for now, folks. Catch you again soon.